Let's take a look at problem 11.2. In this problem here, we have two 15 millimeter steel plates with a yield strength given to us as 400 MPa. These are butt welded using an E70 series welding rod. So this is going to be important when we look up our properties here. And good welding practice, which is going to go into our assumptions. So the wording here is important as far as our assumptions we make. The weld has a length of 90 millimeters. And that they're asking us to find is the maximum tensile load that can be applied to the joint safely with a safety factor of 3. So they give us our SF of 3 there. They also give us this diagram here, 11.2. So we can see here are the two steel plates, 15 millimeters thick, two forces going out this way, and here's our butt weld right there. So we know the weld length, 90 millimeters. We have our yield strength of 400 MPa, our safety factor of 3, and we know it's an E70 series weld. So we've had a chance to read through the problem statement and look at the given schematic. The next step we want to do is write out our solution to the problem. On the first page being the same as before, we want to write down everything that they give us, simplify down the given diagram, figure out what they're asking us to solve for, and to make any assumptions that we can from the problem statement before we start a solution. So the first thing that we do is we take a look at that problem statement and everything they give us and write down what we know. So we're given the fact that there's two plates. We know the thickness of these plates is 15 millimeters, so we can write that down here, that our thickness is equal to 15 millimeters. And we know that it also tells us in the problem statement that our yield strength is 400 MPa. Now it tells us we're using E70 series welding rod. So that's going to be important when we go through and figure out a couple of properties for that from our book. We'll reference back to section 11.4 for that. It tells us that our weld width is 90 millimeters and we have a safety factor equal to 3. Now the thing to think about here is these are in millimeters. We may need to convert these to meters when we go through and solve for a final solution. So they want us to find the max tensile load that can be applied to the joint safely with a safety factor of 3. So we know, again, we have a safety factor of 3 here. And from the problem statement as well, we can go through and figure out that we have a weld efficiency of 100%. And that's given, if we go back to our problem statement, it tells us that it's good welding practice. So with that good welding practice, we're assuming a weld efficiency of 100%. So now we want to go through and begin our solution. And where we want to start for our solution is with section 11.4, where we're taking a look at the specified yield strengths for E70. So now we want to take a look at section 11.4 from our textbook. And this is on page 334. This is for welded joints subjected to static, axial, and direct shear loading. There's a lot of good information in these first 3 paragraphs here that you should read through, but where we want to concentrate is take a look down at the 4th paragraph here. So in the 4th paragraph it says that welding electrode material strength and ductility specifications have been standardized by the American Welding Society, AWS, and the American Society for Testing Materials, ASTM. So we've heard of both of those societies before. Now for us specifically, for example, welding electrodes that we're looking at in our problem here in the E60 and E70 series, where we're looking at the E70 series, are designated E60XX and E70XX. Now, the 60 and the 70 indicates tensile strengths of at least 60 or 70 KSI, respectively. So we're looking at tensile strength here of 70 KSI. Now, the last 2 digits indicate the welding process details, not necessary for our specific problem right now. Specified yield strength for E60 and E70 series. So now we're looking at yield strength. So this is what we need to actually come up with, are about 12 KSI below the tensile strengths. So we want to subtract 12 KSI from our 70 KSI of the tensile strength for our E70 series. So for the next step in our solution, we go back to our assumption where we assumed 100% efficiency based off of a problem statement. And now we want to find our max tensile load that can be applied with a safety factor of 3. So recall this relationship here for our safety factor. The safety factor is equal to our yield strength here times our area over the force, where we're looking for force. So what we want to do is rearrange and solve for F. So F is equal to our SYS times A all over our safety factor here, where our A can be found by the dimensions given in the problem statement. We have the thickness and the length. So we convert from millimeters to meters. So this is 0.015 meters times 0.09 meters. Instead of 15 millimeters and 90 millimeters, we now convert to meters here. So we have an area based off of those dimensions there. We have a safety factor of 3, and we found our value for our yield strength here, 399.6 MPa. We can plug that in. We end up with force is equal to 399.6 times 10 to the 6, because we want to convert to pascals and not megapascals. So our units work out are 0.015 meters, 0.09 meters divided by 3, which when we plug this in, we end up with a force, which is our max tensile load that can be applied, of 179.8 kilonewtons.